In a previous video I played with this almost 100-year-old radio from 1927 and I realized that I need a power supply because the old anode and heater batteries, which you can see here, are of course not available anymore and also a little bit complicated to connect. In the last video I used my bench power supply and the Variac and other power supplies to create all the voltages necessary, and I thought it's time to make a proper power supply for it. Well, and here we are. This is the front panel I already prepared with big holes. That's the power switch. An indicator lamp, the electronics board, which I will explain a little bit later how that works. And today the instruments arrived from China, and even if they are pretty cheap, so one instrument is about $2 to $3, I paid $29 for 8 of them, 4 different, 2 of each. And if I measured that right, this will fit here. Yeah, it's a bit a tight fit, but nothing we couldn't change with a little bit of sandpaper. Let me see if that works better. Well, in fact, I like this style better, mounted from behind. So, oops, that's a little bit tighter than the others. Okay, so that's how it looks. Then power button goes here, or power switch. Indicator lamp here, and here are 2 trim pots for the heater and the anode bias voltage. A little bit of adjustment because I have an adjustable voltage regulator, and I have the 2 putties here. And I will remove them here and put it on the front panel. And I got a wonderful round file here for this thin wood panel. Okay. And now it's time to drill the screw holes here. Let me first place them. So we have 4mm holes. I have a 4mm drill and I have 4mm screws. Everything should be okay. if you drill from this side, the hole will be nice from this side, and if it tears any chips away, so it does it on the back side. That's why I held this wood piece here to prevent the splintering of the wood. So now it's time to mount the power switch. That goes here. Yes. I pre-drilled it with 4 millimeters, but I need 8 millimeters, so I take the bigger drill and make the hole. Unfortunately, I don't have the nut for this switch here. It's a little bit an unusual thread. It's 8 millimeter fine pitch, and most potentiometers and switches have 10 millimeters or 6 millimeters, so I don't have a nut, but I will simply glue it in and hope it doesn't come loose. So with the knob here, everything looks fine. Let me say a little bit something about wood glue. It's the absolute perfect glue for wood, of course, because it goes into the pores of the wood and joins everything together. And when it's dry, and if it's a good glue like this one here, it is almost, or it is sometimes even more stable than the wood itself. So you don't need to screw down everything. If you have the surface to mount it, you can also use glue, and I see no problem. This will hold forever here. I'm using this small PCB here with these large solder pads to connect to the primary wires of the transformer, because the primary wires here are extremely thin, and I think soldering them to another wire would probably break it sooner or later, so I decided to take this piece of board and solder it to that, and then to the next wire that goes to the main switch and also to the mains cable. let me explain the schematic diagram. It's pretty straightforward. It consists of 3 separate power supplies. You can see there are 3 full bridge rectifiers, then a couple or 3 or 4 smoothing capacitors, and the high voltage power supply also has a thermistor, because the 2 100 microfarad capacitors at 180 volts, about that, have quite a large inrush current, and the first time when I turned it on, transistors and Zener diodes exploded, so because the rectifier broke down. So I added this thermistor NTC there. The rest is a simple TIP 47 transistor with a Zener diode, one with a 120 volt diode, and the other one with a 47 volt diode. The problem was I didn't find a 50 volt Zener diode, so I went for 47. That was the closest value to get more or less 50 volts. We have 48 volts, we have 122 volts when I remember right. Then on the low voltage side I have another transformer, the small toroid transformer that you have seen in the video, with 2 windings, so it's in fact 2 transformers. One side makes the 4 volt for the heaters with an LM317 adjustable voltage regulator with a 5 kilo ohm potty and a 330 ohm resistor, and then an output capacitor of 1000 microfarad. And the other side makes a negative voltage of adjustable 0 to 10 volts about. So I take the middle range and set it to -5 volt. That's a negative voltage regulator LM337, also with the 5 kilo ohm potentiometer and a 330 ohm resistor. Also an output capacitor of 1000 microfarad. The only difference is that everything is upside down because it's a negative voltage. So that's about it. Then all the voltmeters are of course connected to the individual voltages here, 50 volt, 120, 4 volt and -5. And well, that's about it. Thanks for watching.